This morning, a newly discovered comet is creating buzz in both the scientific and speculative circles.
Some are calling it a rare interstellar visitor. Others say it could be something much more.
When NASA's instruments trained their gaze upon the region where 3I Atlas has been tracked drifting across the outer reaches of the solar system, the expectation was for further data on a body already celebrated for its status as the third known interstellar object to pass through our cosmic neighborhood. What emerged from that campaign of observations, however, has stunned even seasoned astronomers. Hidden within the shadow of 3I Atlas, a cluster of faint but unmistakable cometary companions surfaced. These objects were not merely drifting randomly in interstellar space. They were on trajectories so closely aligned with 3I Atlas that it suggested a shared origin, or at least a common dynamical history. For the first time, humanity was confronted not just with the solitary passage of an alien wanderer, but with the revelation that it may have been part of something larger, a convoy of icy travelers threading their way between the stars. Before we start, smash the like and subscribe buttons for more updates. The detection itself was an act of scientific persistence. Initial models of 3I Atlas suggested its brightness variations could not be fully explained by the main nucleus alone. Subtle fluctuations hinted at surrounding activity, but they were dismissed at first as jetting or dust emission from the primary body. It was only when deep imaging was processed through advanced filtering techniques that faint secondary objects began to appear. One by one, these hidden companions resolved into distinct comets, their diffuse comas and faint tails shimmering in the reflected light of the distant sun. As the data poured in, the realization spread across the scientific community that this was not a singular interstellar object, but rather the front of a wave. The implications were enormous. Astronomers have long debated whether interstellar comets would tend to arrive as isolated fragments or as larger clustered remnants of a disrupted parent body. The discovery behind 3I Atlas seemed to settle the matter decisively in favor of the latter. Each of the newly revealed comets was following a trajectory nearly identical to that of 3I Atlas itself, as though they had all been released from a common source long before entering our solar system. Their velocity relative to the sun, their inclination, and their hyperbolic eccentricity all matched within a range so tight it defied coincidence. This was a caravan of icy emissaries from another star system sweeping through like an armada. The natural question was how such a collection came to exist. One hypothesis is that these comets are fragments of a larger progenitor that broke apart in the deep void between stars. Interstellar space is far from empty. Collisions with dust, tidal forces from passing stars, or internal stresses built up over eons can cause a once mighty nucleus to splinter. If such an event occurred, the pieces would continue along their original trajectory, maintaining a relative formation. Over the course of millions of years, gravitational nudges might scatter them, but to have reached our solar system still traveling as a group suggests the disruption was relatively recent on cosmic timescales. Another possibility is that 3I Atlas and its companions were ejected together from the same star system, cast out in a planetary migration event, or through close encounters with a massive planet. In this view, what we are witnessing is not the aftermath of a breakup, but the intact ejection of a cometary family. The very fact that these objects remained hidden until now highlights the challenges of detection. Interstellar comets are faint by nature. Their ice is reluctant to sublimate until they are relatively close to the sun. Even then, their comas can be small compared to local comets. The companions behind 3I Atlas were obscured not only by their own faintness, but by the glare of the larger body. Only careful observation revealed their presence, and even then, some astronomers caution there may be more lurking in the same stream, undetected as yet. If true, this suggests that interstellar comets are not rare visitors, but perhaps more common than ever imagined, hidden in swarms that elude casual observation. The trajectories of these comets being aligned has deep significance beyond the immediate surprise of discovery. By tracking their paths precisely, astronomers can back-calculate the direction of origin, effectively pointing toward the stellar nursery or system from which they emerged. The alignment strengthens confidence in identifying that source, because multiple objects on the same course act like a pointer in space. This means the caravan of comets is not merely a curiosity but a navigational clue, a cosmic breadcrumb trail leading back to another star. For planetary scientists and astrophysicists, the opportunity to study matter unambiguously linked to a distant stellar system is invaluable. These icy bodies preserve the chemical fingerprints of their birthplace, allowing comparisons with our own solar system's composition. The chemistry itself becomes a window into the diversity of planetary formation. When spectrographs analyze the comas of these interstellar comets, they can detect ratios of volatiles like water, carbon monoxide, methane, and ammonia. Any deviations from the abundances found in solar system comets would hint at differences in the disk of material from which their parent system formed. Even the isotopic ratios, such as deuterium to hydrogen in water, can reveal whether the conditions of that faraway nursery were hotter or colder, richer in heavy elements or poorer. Each fragment of data is a clue to how planets assemble under varying conditions across the galaxy. The arrival of multiple comets on the same path magnifies the opportunity, for it provides a small statistical sample rather than a solitary outlier. This makes it possible to discern whether unusual readings are intrinsic to the parent system or just anomalies of a single body. Astronomers also recognize that the presence of multiple aligned comets strengthens the case for targeted missions. A lone interstellar visitor passes too quickly for practical interception. By the time its presence is confirmed, it is often already racing out of range, but a train of objects on the same path allows for prediction and planning. If spacecraft cannot catch the leading object, they might still position themselves for an encounter with those trailing behind. This possibility electrifies mission planners, for it holds out the promise of studying alien material up close, perhaps even returning samples to Earth. The sheer rarity of interstellar matter arriving in accessible form makes such a chance almost beyond price. With several objects to choose from, the odds of success improve dramatically. The discovery also forces a reconsideration of the hazards posed by interstellar bodies. While none of the three I-Atlas convoy is currently on a collision course with Earth, the recognition that groups can travel together raises the stakes for planetary defense. If clusters of interstellar comets enter the inner solar system more frequently than previously believed, the risk assessments must be revised. A convoy carries not one chance of impact, but several magnifying potential consequences. Fortunately, the hyperbolic speed of these objects means they spend little time in Earth-crossing zones. But the need for vigilance is clear. Tracking their trajectories with precision is not only an academic exercise, but a safeguard. The philosophical resonance of this discovery is profound as well. Humanity has long dreamed of contact with other worlds. And while these comets are not messengers of intelligence, they are nonetheless emissaries of the alien. Each icy shard is a time capsule from a place we may never visit with ships, carrying within it the record of a star system's birth. To watch them streak past, aligned as though in silent procession, is to glimpse the connectedness of the galaxy. Our solar system is not an isolated island, but a crossroads where materials from many suns may one day converge. The convoy behind 3I Atlas makes tangible the idea that the galaxy is in constant exchange, its systems trading fragments across light years. There is also a sense of deepened mystery. If one convoy has been detected, how many others have slipped through unseen? The detection of Oumuamua in 2017, then 2I/Borisov, and now 3I Atlas with its hidden companions suggests an accelerating pace of discovery, not necessarily because the objects are becoming more frequent, but because our instruments are growing sharper. Surveys like the upcoming Vera C. Rubin Observatory's Legacy Survey of Space and Time will dramatically expand our ability to spot faint, fast-moving bodies. It is possible that within a decade, dozens of interstellar objects will be cataloged, some solitary, others in swarms. The 3I Atlas convoy may one day be remembered as the first hint of a larger pattern, a recognition that such groups are the rule rather than the exception. In contemplating the convoy, astronomers are also reminded of the fragility of such objects. Interstellar comets are volatile rich, and as they approach the Sun, they risk disintegration. 3I Atlas itself displayed signs of fracturing as it neared perihelion. Some of its companions may not survive long enough for extensive study. Their ephemeral nature underscores the urgency of observation, of gathering as much data as possible while the chance exists. Every spectrum, every photometric curve, every astrometric measurement contributes to building a fuller picture before these icy visitors vanish back into the void. Even if the comets themselves disintegrate, their dust and gas will mingle with the interplanetary medium, a fleeting mingling of one system's matter with another. In that sense, the arrival of the convoy is more than a spectacle. It is a small act of cosmic blending. On Earth, astronomers and scientists strain to record, analyze, and interpret. But in space, the exchange happens silently and indifferently. Star systems shedding their debris into one another like seeds blown across fields. This perspective invites reflection on the continuity of cosmic evolution, where every system contributes to the broader galactic ecosystem. As the hidden comets behind 3I Atlas continue their passage, they invite both awe and inquiry. They demonstrate that the galaxy is alive with movement, with matter in flux, and with secrets still waiting to be uncovered. They challenge human imagination to expand beyond the boundaries of the solar system, to envision not just the planets and comets we know, but the vast population of wanderers threading between the stars. They remind us that the story of our cosmic neighborhood is intertwined with countless others, and that sometimes, by chance and vigilance, we catch a glimpse of that greater story unfolding in the night sky. The sudden unveiling of the Cometary companions trailing 3I Atlas did more than surprise astronomers. It ignited a chain reaction of questions that extended well beyond the realm of observational astronomy. Each new comet detected along that trajectory became a seed for hypotheses, theories, and speculations that stretched into planetary science, astrophysics, and even philosophy. When a discovery redefines assumptions as profoundly as this one does, the consequences ripple outward across multiple scientific disciplines, reshaping the way humanity perceives the cosmos and its constant exchange of matter. At the heart of the conversation is the realization that interstellar space may be teeming with far more material than once believed. For decades, astronomers assumed that comets ejected from star systems during planetary formation were rare wanderers, scattered sparsely throughout the galaxy like grains of sand across a desert plain. The emergence of an aligned convoy challenges that assumption directly. Instead of lone fragments cast adrift, there may be streams, bands of fragments traveling together, tied by a shared history. This transforms interstellar comets from a category of rarity into one of potential abundance, suggesting that star systems across the galaxy might constantly seed interstellar space with such debris. If convoys like this exist, then the solar system is not merely visited sporadically, but could in fact lie in the path of multiple cosmic highways, intersections where debris from other stars routinely drifts through. This opens the possibility that interstellar matter has been influencing our solar system for eons, long before humanity had the ability to detect it. Micrometeorites entering Earth's atmosphere might even carry traces of foreign stellar chemistry without our recognition. What 3I Atlas and its companions reveal, therefore, is not a rare event, but an unveiling of a constant galactic phenomenon, only now reaching human awareness, because our instruments have finally become sensitive enough to see it. The discovery also changes how astronomers think about planetary system evolution. Planetary migration is a chaotic process. Massive planets, particularly gas giants, can destabilize surrounding debris fields and eject comets into interstellar space. The sheer number of bodies now seen following the same hyperbolic path suggests that this process is highly efficient, capable of releasing not just one comet, but an entire train of fragments. If these comets are indeed the byproducts of planetary system dynamics, they carry within them the story of that system's architecture, its planets, its instabilities, and its violent past. Studying them is akin to reading the scattered pages of another system's history book, fragments drifting far from the library where they were first written. From a physical perspective, the hidden convoy behind 3I Atlas also provides an extraordinary laboratory for studying the structural integrity of cometary bodies. Comets are fragile, composed of loosely bound ice and dust. To have traveled across the void as a group suggests resilience against both internal stress and external forces. That resilience raises questions about their internal makeup. Are they more compacted than typical solar system comets? Do they possess unusual mixtures of volatiles that preserve them across the freezing dark of interstellar travel? Could their crystalline structures or dust-to-ice ratios differ fundamentally from anything known here? Each answer carries implications not just for their survival, but for understanding how materials from different star systems compare. For planetary defense researchers, the convoy presents a peculiar paradox. On the one hand, the presence of multiple objects provides redundancy in observation. If one disintegrates, others remain to track. On the other hand, it highlights the sheer unpredictability of interstellar bodies. Their high velocities and non-periodic natures make them particularly difficult to track over long timescales, and the possibility of groups increases the hazard potential. The convoy reveals that interstellar visitors are not just curiosities, but factors in long-term risk assessment, reshaping defense planning that had once been focused almost exclusively on near-Earth objects of solar system origin. Beyond immediate science, the discovery stirs imagination in ways that defy boundaries. For centuries, comets have been symbols of mystery, omens in the skies that prompted wonder and fear. To learn that some comets are not even of this solar system but travelers from alien stars amplifies their symbolic weight. They are no longer merely icy remnants of our own planetary formation, but emissaries from distant suns, carrying the signatures of unfamiliar worlds. Each one sparks a sense of connectedness that transcends the boundaries of a single system, reminding humanity that the universe is a shared environment in which matter, energy, and perhaps one day even life, move freely between stellar neighborhoods. The aligned trajectories are particularly captivating in this regard. They evoke the image of a migration, as though these objects are traveling purposefully, not by choice, but by the inexorable pull of gravity and momentum. To the human eye, watching them streak past in parallel arcs is like witnessing a cosmic caravan in motion. That imagery lends itself naturally to cultural reflection, for across human history, caravans have symbolized trade, connection, and exploration. In the same way, this convoy suggests that the galaxy itself is an interconnected web of exchange, with comets serving as couriers of frozen chemistry, binding one star system to another in subtle threads of matter. There is also the practical dimension of exploration. A single interstellar comet is a fleeting target, but a group provides opportunity. The trailing members of the convoy could be studied with increasing sophistication as technology advances. Today, they may be beyond the reach of current spacecraft, but as propulsion systems evolve, a convoy provides a moving ladder of chances, each rung another possible encounter. This motivates the development of rapid response missions, spacecraft capable of launching on short notice, and intercepting fast-moving targets. The convoy inspires not just scientific curiosity, but technological innovation, urging humanity to prepare for encounters that were once unimaginable. At the same time, the detection of these companions underscores the value of persistence in science. For months, their faint signatures went unnoticed, buried in data noise and overshadowed by the prominence of 3I Atlas itself. Only through relentless reanalysis did they emerge, proving that the cosmos often holds its greatest secrets just below the threshold of perception. This is a reminder that discovery is not always about grand new telescopes or missions, but about patience, scrutiny, and the willingness to question assumptions. The companions of 3I Atlas might never have been revealed without the quiet determination of those who sifted through the data. What is perhaps most intriguing is the role this discovery plays in the broader narrative of cosmic origins. Theories of Panspermia, the idea that life might be seated between worlds through comets or meteors, suddenly gain a new dimension. If convoys of interstellar comets routinely cross into new systems, they could, in principle, carry not only frozen volatiles, but complex organic molecules forged in the hearts of alien clouds. Some could even shield microbe-like structures, if such ever existed, from radiation long enough to deliver them elsewhere. While no evidence of life exists in these comets, the concept of them as carriers of the building blocks of biology grows stronger with every detection. They become not just cosmic messengers, but potential agents of continuity between stars. For astrophysicists, the detection provides a real-world test case for models of galactic dynamics. The trajectories of the convoy can be traced backward, perhaps even identifying the stellar system from which they originated. This not only validates computational models of object ejection, but also refines estimates of how frequently star systems shed material. The convoy essentially acts as a tracer particle in a vast galactic fluid, helping scientists understand the currents and eddies that shape the Milky Way's interstellar medium. By charting where these objects came from and where they are going, astronomers gain insight into the invisible architecture of gravitational interactions across light years. The visual impact of the convoy should not be overlooked either. Images of multiple comets aligned along a single hyperbolic path carry an aesthetic power unlike anything previously seen. They embody the beauty of celestial mechanics, gravity sculpting motion into elegance on a cosmic scale. For the public, such images rekindle fascination with space, turning abstract scientific discoveries into spectacles that capture the imagination. They serve as reminders that exploration is not confined to charts and graphs, but lives in the awe inspired by seeing the universe reveal its hidden choreography. Equally powerful is the psychological effect of realizing that these objects come from somewhere else, somewhere real but unreachable. It is one thing to look up at the night sky and know that stars harbor planets. It is another to hold in a telescope's field of view an object that once orbited one of those stars, now passing briefly through our skies. The convoy transforms distant star systems from abstractions into tangible presences, pieces of them brushing past us in icy form. It is a moment of intimacy with the broader galaxy, a reminder that we are part of a vast continuum rather than isolated observers. The questions now proliferate endlessly. How many more comets travel in such streams? Do some of these convoys intersect regularly with star systems, creating a kind of galactic cycle of matter exchange? Could the history of life on Earth be subtly influenced by encounters with such swarms in the distant past? If convoys can survive for millions of years in formation, might they carry within them records of stellar evolution spanning epochs beyond our own? Each question drives further inquiry, and each answer promises to deepen the mystery. The recognition of multiple interstellar comets aligned with 3Y Atlas is thus not just a scientific milestone, but a turning point in cosmic perspective. It reshapes how we think of interstellar matter, how we interpret the processes of planetary system evolution, and how we view the galaxy itself as a dynamic, interconnected whole. These comets are not random wanderers, but coordinated participants in a larger story, fragments of alien systems that now, by chance, intersect with our own. They invite us to look outward with renewed curiosity, to imagine what other caravans may be moving unseen across the void, and to prepare for the discoveries that lie ahead. The convoy of hidden comets revealed behind 3I Atlas opens a door to a narrative that is not only scientific, but also cultural, technological, and existential. Every new comet identified on that aligned path adds texture to the larger portrait of the galaxy, underscoring that what once seemed like a quiet, empty gulf between stars is actually an environment rich with movement and exchange. The consequences of this revelation stretch well beyond astronomy, touching on questions of human identity, exploration, and the future of civilization. One of the most significant aspects of the convoy is how it reframes interstellar space as a place of continuity rather than isolation. For much of modern history, space between stars was considered an inert void with few bodies traveling its cold expanses. The sudden unveiling of multiple comets on the same hyperbolic path forces a reevaluation. Instead of being barren, interstellar space might function more like a cosmic thoroughfare, where materials are continuously transported from one stellar system to another. These cometary streams are not static. They are the residue of gravitational interactions, the fallout of planetary migrations, and the fingerprints of stellar encounters. The galaxy begins to appear less as a scattering of islands and more as a dynamic archipelago linked by drifting debris. This realization ties directly into humanity's long-standing curiosity about cosmic chemistry. The solar system is not sealed from the rest of the galaxy. It is permeable, open to influences that arrive from great distances. With convoys like this moving into and out of planetary systems, the galaxy becomes an environment of ongoing chemical conversation. What 3I Atlas and its companions suggest is that the solar system has likely been touched repeatedly across billions of years by material born around other suns. This intermingling provides opportunities for new compounds, exotic isotopes, and molecular structures to find their way into systems far removed from their origin. For astrobiology, this is a profound idea because it strengthens the plausibility of prebiotic molecules moving across stellar boundaries. If amino acids or nucleobase-like compounds were ever formed within these icy bodies, their transport across the galaxy could become part of a larger narrative of life's building blocks circulating widely. The presence of several bodies traveling together also deepens the complexity of how scientists model interstellar debris. A single comet is challenging enough to track. A convoy of objects requires a nuanced approach. Each body, while moving in roughly the same direction, will undergo slightly different gravitational perturbations as it passes through the solar system. These perturbations, caused by the planets, the sun, and even mutual interactions among the comets themselves, create a tapestry of diverging yet parallel paths. For astrophysicists, this becomes a unique opportunity to study orbital mechanics in action. The convoy acts as a natural experiment, where the laws of motion can be observed across multiple similar bodies simultaneously. Differences in trajectory can illuminate the subtleties of gravitational influence at work within the solar system, offering lessons that can later be applied to the understanding of planetary dynamics in other systems. One of the most fascinating implications of these cometary companions is the way they might be used as tracers of galactic history. Just as paleontologists use fossils to understand the environments of Earth's deep past, astronomers can use the convoy as evidence of ancient stellar events. The original source system may have undergone dramatic planetary rearrangements, where giant planets hurled icy remnants outward with enough velocity to escape into interstellar space. Those comets now serve as living fossils of that era, physical relics of processes that occurred around another star long before humans ever looked to the skies. To study them is to piece together the archaeology of a foreign system. The convoy thereby bridges the present to the deep past of another world, connecting epochs across light years. In terms of exploration, the convoy's revelation could inspire one of the most ambitious technological goals of this century: the interception of an interstellar object. Missions to interstellar targets pose enormous challenges, primarily because of the speeds involved. These bodies hurtle through the solar system at tens of kilometers per second, giving scientists little time to react. Yet the presence of multiple aligned comets changes the dynamics. If the first passes too quickly to intercept, others following behind may still be within reach. This creates the potential for staggered opportunities, a series of targets rather than a single fleeting chance. Such a configuration allows mission designers to test propulsion systems, trajectory correction maneuvers, and even high-velocity flyby technologies, refining techniques with each successive object. In this way, the convoy functions almost like a training ground for interstellar interception. From a cultural perspective, the convoy enhances the symbolic role of comets in human imagination. Comets have been seen for millennia as harbingers of change, woven into myths and prophecies across civilizations. The knowledge that some comets are literally visitors from other stars gives these cultural associations new depth. They are not only symbols of transformation but embodiments of the universe's interconnectedness. Every comet trailing behind 3I Atlas becomes a reminder that humanity's story is not written in isolation. We share the galaxy with countless systems, and fragments of their histories are now brushing past our own. For artists, poets, and storytellers, this transforms comets from local phenomena into true galactic emissaries. The sky is no longer just our solar system's canvas, but a galactic stage on which distant systems leave their marks. The convoy also sharpens the question of cosmic hazards in ways that had not been previously considered. While interstellar comets are rare on human timescales, their high velocities mean that even a relatively small body could release extraordinary energy upon impact. With multiple objects traveling together, the statistical chance of close approaches increases marginally, enough to warrant new levels of vigilance. This adds an interstellar dimension to planetary defense. Until recently, near-Earth object surveys were designed primarily to track asteroids and comets bound to the Sun. Now, detection systems must also consider hyperbolic intruders, fast-moving bodies that offer no periodic returns for tracking. The convoy demonstrates that vigilance must expand beyond solar system dynamics into a broader watch of the interstellar background. There is also a subtle but transformative effect on the philosophy of exploration. For centuries, humanity has looked outward with a sense of vast separation between ourselves and the stars. But when fragments of other systems enter our skies, they collapse that distance. The galaxy is not an abstract map of unreachable places, but a real environment whose contents occasionally arrive uninvited into our observational field. This creates a shift in perspective. Humanity is not just observing the galaxy from a distance, but participating in its ongoing exchanges. The convoy makes clear that boundaries between star systems are porous, and that even in the immensity of space, material bridges exist, invisible until moments like this reveal them. One cannot overlook the role of technology in all of this. The discovery of the hidden convoy was not inevitable. It depended on the precision of modern detectors, the refinement of imaging algorithms, and the computational ability to filter faint signals from noise. Without these, the companions might have remained invisible, their passage unnoticed. This underscores how advances in observational technology not only expand our reach, but also alter our understanding of reality itself. Every leap in detection capability opens new dimensions of the universe. The convoy demonstrates that hidden layers exist even in phenomena we believe we have already cataloged, and it emphasizes the value of continually pushing the limits of what instruments can see. In many ways, the convoy also acts as a mirror for humanity's curiosity. The alignment of the comets suggests coherence and almost narrative quality in their arrival. They appear as a procession, a sequence that invites interpretation. Human minds naturally seek stories in patterns, and here the cosmos provides one. The story is not about deliberate purpose, but about natural processes, gravitational interactions, disruptions, and ejections that produce a result that feels coordinated. In watching the convoy, humans are reminded that the universe is capable of generating beauty and coherence without intention. It is a narrative written by physics, not by design, yet no less evocative for that. If you liked this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us, what are your thoughts on NASA revealing hidden comets behind 3I Atlas? We want to hear from you. Thank you for watching, and see you next time.